Welcome to Sand Learning. In this video, let us see the minimum number of states in the finite state automaton. How to construct minimum number of states in a finite state automata for a given table, transition table, or for a given transition diagram. This type of question was asked in June 2021 NET exam. Let us see the question. What is the minimum number of states required to the finite automaton equivalent to the transition diagram given below? The transition diagram is given and we have to identify the minimum number of states required in a finite state automaton. The options given are 3, 4, 5, 6. Let us see how to convert this transition diagram into a minimum number finite state automaton. We have to follow different steps. First, let us solve this problem and I'll give you the steps to be followed to identify the minimum number of states in a finite state automaton. The first step is we have to identify the set of non-reachable states, not reachable states. So in this diagram, if we check the non-reachable state, how to identify easily the non-reachable state means find out in the set of all the states, the state which has no incoming edges. So here if we see A, there is one incoming edge, so it can be reachable. And for B, we have one incoming edge, so it can be reachable. C, we have one incoming edge, more than one, so we can reachable. And D, there is no incoming edge, so which cannot be reachable. And E is a state which can be reachable through just this G, and F can also be reachable, G and H. So all the states can be reachable except the D. So we have to omit this non-reachable state from the diagram, and now the diagram contains only this number of states. The second step is we have to construct the transition table. So how to construct the transition table means we have to take all the set of states. From that state, if it goes to 0 transition, where it goes to, we have to identify, and for 1 transition, where it goes. So with that information, now we have to construct the transition table. Let me construct the transition table. So the available states are A, B, C, E, and then F, G, H. So these are all the set of available states. So we have to identify the transitions. If start from A, 0 transition where it goes, and for 1 transition where it reaches. So for A, if it is a 0 transition, it goes to B, and for 1 transition, it goes to F. Similarly, take B. For B, it goes to G and C. For 0 transition, it goes to C, G, and for 1 transition, it goes to C. And take C, it goes to A and C. And for E, it reaches H and F. And for F, it goes to C and G. For G, it reaches to G, E, because G has the same, that is incoming transition with 0 to the same state. And take H. So for H, the transitions are G and C. So this is the transition table. Yes. Now let us go to the third step. So the third step is we have to construct two different set of states. One is the set of all non-final states and then the set of all final state. So we have to form two different groups. The first group is set of all non-final states and the second one is set of all final states. So in the third step, we have to form a two different group. Let me name the group as A. A is a set of all non-final states. So here in this diagram, we have to mark what is the starting state in the transition table. A is the starting state, and what are all the different state? The final state, set of all final state. C is a set of all final state. So we have to mark all the final state, the transitions in the transition table, and we have to form the set of all non-final state. So the non-final state is A, B, and then E, because C is the final state, F, G, H. And let me name the set of all non-final state as only one final state. So let me mark that as C. So there are two different groups. The first group is set of all non-final states, and the second group is set of all final states. So with this, we are going to proceed to the next step, fourth step. In this step, we have to form a different group if there is a transition for a particular state leads to another group. For example, let us consider B. So for this B, the 0 transition will leads to G, which is in the same group, and G, and the 1 transition which leads to C, which is another group. So in that case, we have to separate this E from this group. And the other thing is, if for the transition and 0 and 1, if it leads to this same group, then we can keep that particular state in the one group. Otherwise, we have to separate that particular state and keep it as a separate group. So now let us see A. So A, which 0 transition and 1 transition, we have BF, which is available in the same group. So B and F, which are available in A. So let's consider A in the same group. So A will be in this group. Take B. B is a 0 transition G, which is available in the same group, but the transition 1, it leads to another group. So we can separate B and keep it as a separate group. So let me mark that as C. So in the C group, let me place B. And then go to E. E, the transition is HF. So HF, both are available in the same group. So I can place E in the group A. And then take F. F transition is one is C and G. C is available here and G is available here, which is another group. So let me put this F over here. And then take G. The transition is G and E, which is in the same group. So let me place G over here. And take H. H is the transition is from one is G and C, which is in different group. So let me place H over here, and the new group is B, which contains the F, H, and the next group is the set of all final state, that is C. Let me mark it as C. Now again, the fifth step, we have to repeat the fourth step until there are no new final states. So we have to repeat this step again and again until no more new states which can be generated from this particular group. So let me go to the fifth step. So we have to repeat the step 4 to find out whether there is any new state which can be generated. Consider this A. A, the transition is B and F, which leads to another group B and F, so which is available in group B. So let me mark that in the same group. Let me keep that in the group A, because this A, it leads to another group B, F, so which is available in B. And then take E. E is H and F. So H and F is also available in the same group B. So I can place E in the group. So while placing this, if more than one state which leads to the same state means, then we can group all those states in one. one group. So here A which leads to B and F, which is available in B, E which leads to H and F, which is also available in B. So we can group A and E together, and take G. G, here the transition is GE, which is available in the group A. So we can keep this in a separate group. Let me mark that group as B. So we are separating G because G which goes to the group A, E, G, the same group A. So here the G is separated from this group. Next C, C is always in the final state. So C is the final state, so we have to place it. And then go to B. Here B, F, H, take B. So B which leads to GC, which is in different group. So we can place B in a separate group, that is D. Let me mark that as D. Let me see whether there is some other is forming. And next take F, F to CG. So which is take F. F is CG. CG, but it is in the reverse order. So let us place F separately. And then H. H is, the transition is GC, which goes to B and C, the same transition of B. So let us place B and H together, and this F as separately. So this state is D and this state is E. And we are going to repeat this again. Again see AE. So A is BF, E is also HF, which falls on the same group. So no more separation is possible. And then G, it is a single state, C is another single state, F is another single state. Let me check BH. BH is which leads to GC, the same group. H is also GC, which leads to the same group. So with this we have completed the separation of groups. Now we have to see how many groups are available. So here A, B, C, D, E. So totally 5 groups are available. So the minimum number of states required to construct the finite state automaton corresponding to this transition diagram is 5. So after this we can draw the transition diagram with the states. So here the first state is which contains A, E. So we can consider that state as a single state. So from that we are going to start. So this is a starting state. And then we have BH. So BH which can be combined together and it can be denoted with one single state. And then take and C, we have a C as a separate state. So one C state is a separate state, and then G is another state, F is another state. So let me place F over here, F, and then G over here. Let us connect all the states so that we will be able to get the minimum number of states in a finite state automaton. So A and E which are connected to the transition BH with the transition 0. So if we see A, the transition is 0 with B, and E, H. So both are available in the same group. So the transition 0 leads to BH group, and then the transition 1 leads to F group, F. So 1, here the transition is 1, and then for both A and E, the transition 1 leads to F. So I can mark it as here F, and then take BH, the transition 0 which leads to G, and the transition 1 which leads to the group C. So this is 1, and C is the final state. Yes. and take C. So C, the transition 0 which leads to AE, the group AE. So this is 0 transition, and the transition 1 which leads to the same group. So let me make this with the looping 1. So the transition 1 which leads to the same C, and then F. So here F, the transition 1 0 which leads to the group which leads to C. So here the transition 0 which leads to C, and the transition 1 it goes to G. And take G, the transition 0 which goes into the same state. So let me mark with the looping edge 0, and for 1 it goes to AE, the first group. So for 1 it goes to the group here. So it is 1. So this is the minimum number of states finite state automaton. So how to construct the minimum number of state or find out the minimum number of states for a particular transition diagram or transition table means we have to follow these states. Let me summarize the points again. The minimum number of states in a FSA which can be constructed by following all these steps. The first step is find out the states which cannot be reachable and discard all those states. So we have discarded D in this particular diagram. Then second, construct the transition table with the remaining set of states. Third step is divide the set of states into two different states called A and B, where A contains all non-final states and B contains all final states. It's not necessary that you have to always denote the group with A and B. You can have any name. For example, you can have B or C, or you can have P, Q, any name you can give. And then the fourth step is consider each state and its transition on input symbols. If for all the input symbol its destination is in the same group, then keep it in the same group, otherwise construct a new group with a different name. Fifth step is repeat the step 4 until no more new group is generated. The total number of group is the minimum number of states required to construct the finite state automaton. Thank you for watching this. Kindly subscribe my channel.